This is the second standard in grade 3. Understand a fraction as a number on the number line. So let's really look at the number line. Now, remember, the very important thing in fractions is to designate an unambiguous whole. Before we do anything, any partitioning and all that, we need to designate an unambiguous whole. In this case, the whole represents the length of 1 on the number line. This represents the whole right there. Okay. Now it wants us to think of, let's just think of 1/2. Let's think of 1/3. And let's think of 1/4. Each on their respective number lines. It wants us to think of, remember, 1 over b, in this case b is 2. We defined the interval 0 to 1 as the whole, the length of it as the whole, and we're partitioning it into 2 equal parts in this case. So as we can see, it's partitioned into 2 equal parts. And that each part has size 1 over b, so each part has size 1 over 2. Let me write that above here. So this has size 1 over 2. This has size 2 over 2. This is 3 over 2. This is 4 over 2. This is 5 over 2. And this is 6 over 2. And specifically, 1/2 would represent this, the length over here. 1/3, the whole, which in this case is the length of 1 on the number line, is partitioned to 3 equal parts, and it's the length of one of those parts. So that would represent 1 over 3. This is 2 over 3, 3 over 3, 4 over 3, 5 over 3, 6 over 3, 7 over 3, 8 over 3, and this is 9 over 3. Again, the whole, in this case the length of 1 on the number line, is partitioned into 4 equal parts, and 1 over 4 represents the size of the smallest interval with 0 as the endpoint. So it represents that. This is 2 over 4, 3 over 4, 4 over 4, etc., etc. 6 over 4, 7 over 4, 8 over 4, 9 over 4, 10 over 4, 11 over 4, and 12 over 4. So it makes it clear what a unit fraction is on the number line. And again, visually we can see as the denominator gets larger and larger, the interval gets smaller and smaller. This, of course, should be 1 over 1. Let me make that very clear. Okay, now the next thing it wants us to do is consider the cases such as a over b. So when we think of a over b, we're really marking a lengths 1 over b from 0, and the resulting interval as size a over b, and that its endpoint locates a over b on the number line. So for example, what is 3/2? 3/2 is really, again, 3 copies of 1/2, so it really represents, here's 1, 2, 3. That would represent 3 over 2. 4 over 2 would represent 4 copies of 1 over 2. So 1, 2, 3, 4. That would represent 4 over 2. Now let's look at 7 over 3. That represents 7 copies of 1 over 3. 1, 2, 3, 4, 5, 6, 7. It's the length of those. So we can see a over b, we're really for example, 7 over 3 is, we're really marking 7 lengths of size 1 over 3. And the resulting interval is size 7 over 3. And that its endpoint, right, from 0, its endpoint is right here. That's how we locate it. What it means by that, it's really 7 copies of 1 over 3, right? Here's 1, 2, 3, 4, 5, 6, 7. Okay? So that's what 7 over 3 is. And how do we represent, let's do one last one, 6 over 4. That's really 6 copies of 1 over 4. 1, 2, 3, 4, 5, 6. So now we're really looking at the number line, as our approach. And another interesting observation, let's just point that out, we'll go more in depth later, is that notice how 2 is the same thing as 4 over 2, which is the same thing as 6 over 3, which is the same thing as 8 over 4. So this is kind of we're getting an intuitive feel for equivalent fractions.